So as I mentioned before, the availability of the nitrogen does have a relationship to the type of material that you're using out there. If you've got a material, think of something like sawdust, which is the extreme. It's got a very high carbon content, very low nitrogen content. If you use that in the soil, what will happen is the nitrogen from that will eventually become available, but not for a long time, because there's so much carbon in there. Okay? When you have something that has more nitrogen in it and less carbon, that nitrogen becomes available much more quickly. So again, typically a soil, the carbon-nitrogen ratio in a soil is around 10 to 12 to 1. Okay? And then this just gives you an idea. Bacteria and fungi are below that. Leaves, and then you've got sawdust, straw, which are higher in carbon. And again, it's going to mean that they're going to be less available. And in fact, they can actually reduce the amount of available nitrogen. Because what happens when you put a highly carbon material on soil is the soil microbes use that as a food source. And they're going to be chewing up that carbon, but what they need is also nitrogen. They're going to have a population explosion. They're going to pull whatever available nitrogen is in that soil and pull it to use for their own bodies as they start munching on this carbon. And as a result, you can induce a nitrogen deficiency if you put a very high level of carbon-type material on it. Eventually, as the soil warms and the microbes do their job, the microbes will start to die, and the carbon and the nitrogen that they used will start to become available. Sort of as a slow release type of thing. But that's why it's related to the carbon content of the material. And then this was just some work where they looked at some different fertilizer materials and some soil amendments that could be used. And you can see here in one column we've got the percent nitrogen that's in that material, and then the carbon to nitrogen ratio is in the next. And what we have is the percent of nitrogen that's converted over to nitrate 20 days and 40 days later. And this was at, I think, about 60-degree temperatures. And you can see that, in 20 days, looking at something like soybean meal or cottonseed meal, over about half of it, maybe more, was available as nitrate. Okay. But when you look at some of the other materials, take wheat straw or the horse manure that, the horse manure that has synthetic in it, has a higher carbon content. And you can see I put that in red because 20 days and 40 days afterwards, we're still in a negative. We've actually taken more nitrogen out of the soil. It's in the microbe's body at this point. Okay? But again, because of the higher carbon content, eventually that nitrogen will be available to the crops, but the higher the carbon content, the more slowly that's going to be available. So what happens to the nitrate? Well, hopefully, the nitrate that is in the soil is going to be picked up by the plant. Okay? That's what we'd like to see. Some of it's going to be used by the microbes, as we talked about, as they break down some of the carbon materials in the soil and break down the organic matter and the humus that's out there. If you have a very heavy rain, and you've all seen this, a field that heavy rain and the water's puddling on top, and you see a large yellow area out there, where, again, the crop doesn't look good. And you think, well, probably the roots died back. Well, that's part of it. There's part of it in that the roots have died back and you're not getting the absorption. But what's also happening is the microbes that are in the soil are actually using the nitrate, NO3. If there's no oxygen in the soil, they will use this as a source of oxygen. And when they do that, then they're releasing some nitrous oxides. They're using the oxygen, what's left over, in a very inefficient reaction, but something they're using just to stay alive, will release the nitrous oxide. So you don't like to see that. And the most important thing we worry about is the potential for leaching, because it's a negative charge. Remember, the ammonium was a positive charge, nitrate is a negative charge, and negatively charged ions have a tendency to leach through our soils. The sandier, more gravelly the soil, the more likely it's going to leach. Less organic matter in the soil, the more likely it is that it's going to leach. So when we look at what is being recommended for nitrogen in New York, okay, generally it's anywhere from 50 to maybe 90 or 100 pounds of nitrogen per acre total for the year. The question that always comes up is when is the best time to apply that nitrogen? And remember, we want to make sure that we have a really healthy, vigorous plant that's growing in that field in the spring when the garlic starts to mold. So, some of you that have been working with garlic for a number of years probably remember Angela O'Callahan. She was a student here getting her master's degree about 15 years ago at Cornell, and she was working with Royal Rock, and she was working in garlic. And they did a lot of work looking at nitrogen utilization in garlic. And to tell you the truth, when Crystal and I have looked in the literature to see what's been done in garlic, there hasn't been a whole lot done really since then. And I'm glad to see Crystal's doing some work on it, because I think we really need to revisit some of our, getting back to what's the best way to apply this. They looked at rates, and they looked at this over a couple of years. And what I've tried to do is I've gone through and I've pulled out some of the work that they did. This was from 1998, where, again, these are the yields. And I know these yields probably look pretty high. But you have to remember this is on small plots. So it's relative. You know, you don't want to compare these yields to what you're getting, but just compare them in terms of the other numbers that I've got on the table here. So, and this was work that was done down in Ithaca. So again, where they were using, it seemed like, 45 pounds of nitrogen, applied nitrogen, all of it being applied in the spring. They were not doing any fall applied nitrogen. It seemed to give you an adequate yield. That above that, by doubling the rate, there wasn't any increase in the yield. And you look at it in terms of 1999, and sort of the same trend is there. Even though in the zero rate, they're still getting a pretty decent yield out of that. Looking at the soils they were using, it seemed like it was pretty low in organic matter, so I'm not sure why they seem to be getting such a decent yield out of the zero treatments. But I think the thing to pull out of their work is that there really wasn't an advantage with really going more than 45 to 50 pounds of nitrogen per acre. They also did some work where they were looking at timing of that nitrogen application in the spring of the year. And they were at first looking at it in terms of growing degree days. But what it seemed to work the best for them was applying the nitrogen based on the growth of the plant, which, of course, in a way is related to the growing degree days. Okay? So they're applying this in the spring when garlic had 3, 5, 7, or 10 leaves. What they found was that the best yield was when they applied early. Okay? And this was with, everything they were using here was ammonium nitrate fertilizer. Look at it again in 1999, a year later, and again, although the yields are pretty good for all of those, they still seem to get the highest yield when they're applying it early at the 3-leaf stage. They also looked to see whether maybe a split application would be better. And in 1998, again, the 3-leaf stage was reached on the 31st of March. And what they found there was whether you put all 90 pounds on at that point, or whether you split it up and applied some, a month later, and you can see the different treatments that we've got, didn't really seem to have an impact on the yield. Okay? That, again, putting a higher amount on in the spring of the year, the first application, and then the plants at the 3-leaf stage, seemed to give the best yield that they had in that situation. And again, looking at it the following year, doing another split application, and again, they found that, again, the earliest application here was the 4th or the 3rd of April, certainly gave you a highest yield in the study. Really, the one thing that this really points out, too, in some of the other years I didn't put in here, is that when you reach that 3-leaf stage or the 5-leaf stage, it really can vary from year to year, as you know, depending on the type of year. Think about the March we had last year, how warm it was, and probably where your garlic was at that point, as compared to where it is this year. So again, that's why it's probably best not to think about it in terms of applying it based on the calendar, but really applying it based on the stage of growth of the garlic plant. I think that was the bottom line. Make sure you're taking credit for the nitrogen that's in your soil. As I mentioned, if you do a soil test, you will get a % organic matter. And from that % organic matter, you can estimate that there'll probably be anywhere from 15 to 20 pounds of organic matter for every 1% organic or nitrogen available for every 1% organic matter. So if you've got a 2% organic matter, you could expect anywhere from 30 to 40 pounds of nitrogen being available. And I know for many of the garlic growers who, again, really have some excellent soils out there, you might be looking at 3.5 or 4%. And with that, you're looking at 50 to 60 to 80 pounds of available nitrogen that's going to be available to that crop. Do you have any legumes or cover crops that were turned in? What was the nitrogen content of any of the manure or compost that you used? So the soil organic matter is a key. So again, based on what Angela and Royal Rock did back in the late 1990s, It seems like the best time to apply the nitrogen is at the 3 to 5 root stage. 50 pounds of nitrogen seems to be appropriate. Going above that didn't seem to be giving us any greater yield. The one thing they caution is that if you do wait, it seems like there's a long-term effect, that nitrogen or the garlic can't recover from an early nitrogen deficit. And if you're using, again, when they were using ammonium nitrate, they didn't see any difference between the one application or a split application. They're putting all that nitrogen on at the early part seemed to do just fine. Okay. So the question comes in, what about the fall applications? You'll see, you'll read recommendations in other states, they talk about putting half of the nitrogen on in the fall. Concerned about that because do we really need that and run the potential that we could be leaching? And think about when we plant the cloves in the fall, we're actually putting down in the cloves themselves nitrogen. It's available to that developing plant. Okay. Doing some calculations, okay. The nitrogen level, the nitrogen that's available just from the cloves alone is probably about 1%. Okay. So if you do the math, figure out how many cloves you're putting out there, the weight of the cloves you're planting out there, we're probably looking at anywhere from 10, 15 pounds of nitrogen that's available. And when I say available, I'm talking about nitrogen that couldn't be more available. Because what's happening when you plant that clove and you're getting the roots formed, all of the nutrition is coming from that clove. It's coming from the nitrogen and the protein that's being broken down. Okay? So the thinking here is that we probably don't need to apply any additional nitrogen until very early spring, at that 3 to 5 root stage. Okay? Because for the most part, we're probably getting enough nitrogen from the clove that was planted in the fall. Okay, so we're getting that good root development.